It is late, and your body feels wired in a way that rest cannot seem to reach. What you are feeling has a name and a chemistry. A hormone called cortisol, still moving through you at the hour the night was asking it to fall. And here is the quiet, unexpected part. The signal that lowers it is not a thought, and not a pill. It is something your body reads from the room around you. Welcome to Sleepy Science Facts. Tonight is not about switching cortisol off. It is about reminding a very old clock what hour it has become. Close your eyes. Let your shoulders lower. Somewhere beneath thought, a rhythm older than worry is already turning, already preparing to gently bring you down. And now we begin. There is a hormone that helps wake you, and the same hormone, when it lingers, can keep you from sleeping. Its name is cortisol, and it is not a flaw in your design. It is one of the oldest signals the body uses to organize a single day. Long before anyone learned to worry about lost sleep, this molecule was rising near dawn and easing toward dark, tracing a curve nearly as dependable as the sun itself. The question this quiet hour follows is a soft one. What signal tells the brain that the hour for high cortisol has passed? And why might that signal settle the body more gently than anything swallowed? We begin with what cortisol is actually for. Cortisol is made in two small glands that sit just above your kidneys, called the adrenal glands. Each one is no larger than a walnut, yet together they help set the tempo of your entire day. The outer layer of each gland, the adrenal cortex, releases cortisol in slow, measured pulses. It does not flood the bloodstream all at once. Instead, it arrives in gentle waves, roughly once an hour, like a tide that knows its own schedule. Researchers describe this as pulsatile release, and it appears to be the body's preferred way of speaking in hormones. Not a shout, but a steady, rhythmic murmur beneath everything else you do. For a long time, cortisol was described simply as the stress hormone, as though its only job were to respond to trouble. That description is true, but it is far from complete. Cortisol also helps you wake, helps steady your blood sugar through the morning, and helps shape when you feel alert and when you feel ready to rest. Calling it only a stress hormone is a little like calling rain only a flood. The same substance that can overwhelm a system in excess is, in its ordinary rhythm, one of the things that keeps that system alive and oriented in time. The instructions for cortisol do not begin in the adrenal glands. They begin in the brain, in a small region called the hypothalamus. The hypothalamus sends a chemical message to the pituitary gland just below it. The pituitary sends its own message into the blood. And only then do the adrenal glands respond by releasing cortisol. Scientists call this chain the HPA axis. After the hypothalamus, pituitary, and adrenal glands, it is a slow, deliberate conversation that travels downward through the body, one link at a time. And understanding tonight's question means following that conversation patiently back to where it first begins. The HPA axis has a quiet feature that makes it self-correcting. Once cortisol rises in the blood, it travels back up to the brain and signals the hypothalamus and pituitary to ease their messages. The output becomes its own brake. This is called negative feedback, and it is how the body keeps cortisol from climbing without end. In a calm and well-timed system, the loop closes smoothly. The signal goes down, cortisol goes up, and the rising cortisol gently tells the signal to quiet again. Much of restful sleep depends on this loop being allowed to complete itself in the dark. Cortisol does not stay at one level through the day. It follows a curve, and that curve is remarkably consistent across healthy people. It tends to be lowest in the first hours of deep night, climbs steeply in the hour around waking, reaches its daily peak shortly after you open your eyes, and then drifts downward across the afternoon and evening. By the time you are settling into bed, it is meant to be approaching its lowest point again. This daily shape is called the diurnal cortisol rhythm, and it is one of the most reliable patterns in all of human physiology. That sharp climb just after waking even has its own name. It is called the cortisol awakening response, and it appears within the first 30 to 45 minutes of opening your eyes. For most people, cortisol rises by roughly half again above its already climbing morning level during this short window. It is thought to help the body shift from sleep into the demands of the day, preparing energy and attention before you have taken a single conscious step. Far from being a malfunction, this morning surge is one of the clearest signs that the rhythm is working as it was meant to. If morning is cortisol's high tide, then the late evening is its low tide. In a healthy rhythm, cortisol in the hours before sleep falls to a small fraction of its morning peak. This evening low is sometimes called the cortisol nadir, and it usually arrives in the first half of the night. The descent matters, because a falling cortisol level helps clear the way for sleep-supporting signals to take over. When the evening decline happens on schedule, the body reads it as permission to begin letting go. Tonight's gentle goal is simply to help that decline arrive on time. So what keeps this curve so steady, day after day? Even when your schedule changes, the answer lives in a tiny cluster of cells deep in the brain, in a part of the hypothalamus called the suprachiasmatic nucleus. It is often shortened to the SCN, though it holds only about 20,000 neurons, a vanishingly small number compared with the billions in the brain. This cluster acts as the body's master clock. It keeps near daily time on its own, and it sends timing signals out to the rest of the body, including, indirectly, to the adrenal glands that make cortisol. The remarkable thing about the master clock is that it keeps running even in complete darkness. In careful studies where people lived without any time cues, their cortisol rhythm continued to rise and fall on a cycle close to 24 hours. The internal clock does not depend on the outside world to keep ticking. But here is the first hint of tonight's larger idea. Although the clock runs on its own, it does not run perfectly. Its natural cycle is slightly longer than a true day, which means it has to be nudged back into alignment, gently, every single morning and every single night. That nudge is the heart of the story. Because the internal clock drifts a little each day, it relies on outside signals to keep it set to the real world. Scientists call these signals Zeitgebers, a German word meaning time givers. A Zeitgeber is anything in the environment that tells the clock what hour it actually is. Light is the strongest of them. Temperature is another. The timing of meals is a third. Tonight's question is really about these time givers, and how a few minutes of the right ones, offered in the right order, can help an out-of-step cortisol rhythm find its way back toward the dark. When cortisol stays high at night, it is usually not because the adrenal glands are broken. More often, the clock that times them has drifted out of step with the actual hour. Late light, late meals, irregular schedules, and lingering stress can all shift the rhythm so that the evening decline arrives too late, or only partway. The cortisol you feel at midnight is, in a sensor, yesterday's afternoon refusing to end. This reframing is worth holding gently. The goal is not to fight the hormone. The goal is to help its timing slide back to where the night already wants it to be. Cortisol and sleep are bound together in a kind of mirror image. As cortisol falls in the evening, another signal, the sleep hormone melatonin, begins to rise. The two trace opposite curves across the night, one descending while the other climbs. When the rhythms are aligned, cortisol's low point and melatonin's rising tide overlap in a way that smooths the passage into sleep. When cortisol stays high, it can blunt that rising melatonin signal and hold the doorway closed a little longer. So part of helping sleep arrive is simply helping cortisol step aside on time, leaving room for the quieter hormone to take the lead. The body does not only release cortisol from a clock, it can also release it in response to a perceived threat. And this is where nighttime worry enters the picture. When the mind registers something as a danger, even a thought about tomorrow, the hypothalamus can activate the HPA axis directly, sending cortisol upward regardless of the hour. This is helpful when a real challenge stands in front of you. It is less helpful at 1 in the morning, when the only thing present is the dark and a racing mind. The same axis that organizes your day can, at night, be triggered by imagination alone. There is a second, faster stress pathway worth knowing, because it explains why some nights feel so physical. Alongside the slower cortisol system, the body has a rapid branch of the nervous system that releases adrenaline within seconds, quickening the heart and sharpening the senses. Cortisol follows more slowly, over minutes, to sustain and manage that response. So the wired feeling of a sleepless night is often two systems at once, a quick electrical alarm and a slower chemical one. Calming the body means speaking to both, and gently. The same environmental signals that lower cortisol also help quiet the faster branch. Here is a detail that points toward tonight's method. The adrenal glands do not only listen to hormones drifting down from the brain, they also receive direct nerve signals from the nervous system, including pathways that carry information about light and dark. Research in animals has shown that the master clock can influence the adrenal gland through these nerves, not only through the slow hormonal chain. The picture is still being refined in humans, but the implication is gentle and hopeful. There may be more than one road by which a signal of evening can reach the gland and ask it, quietly, to lower its output. Consider how light reaches the clock at all. Your eyes contain the familiar cells for seeing shapes and colors, but they also contain a smaller, separate set of cells whose main job is not vision, but timekeeping. These special cells, called intrinsically photosensitive retinal ganglion cells, respond most strongly to bright, bluish light. They send their signal not to the part of the brain that forms images, but along a dedicated path straight to the master clock. In other words, your eyes are quietly reporting the time of day to your internal clock, whether or not you are paying any attention to what you see. Those timekeeping cells carry a pigment called melanopsin, and melanopsin is most sensitive to the short wavelength light we perceive as blue. This is the light that fills the open sky at midday and, in a different form, glows from screens and bright indoor bulbs at night. To the master clock, a bright bluish glow late in the evening can read as a small, false dawn. The clock interprets it as a signal that the day is not yet over, and it can delay the evening fall of cortisol and the rise of melatonin. The light itself is harmless. Its timing is what the clock reads. This is why the absence of bright light at night is itself a signal. When the timekeeping cells stop receiving strong blue light, they quiet down, and the master clock receives the message that darkness has arrived. That message helps release the evening cascade, easing cortisol downward and allowing melatonin to rise. Dimming the lights, then, is not merely a comfort or a habit. It is a direct instruction to a specific set of cells, which pass it to a specific cluster in the brain, which in turn helps time the hormone you are hoping to lower. A small change in light is a real message. It helps to know that the clock weighs light differently depending on the hour. The same brightness has a far larger effect on your rhythm in the evening and early night than it does at midday. In the hours before your usual bedtime, the clock is especially sensitive, and even modest indoor light can nudge it. This is sometimes described as the clock's phase response, its changing willingness to be moved at different times. The practical meaning is gentle. The dark you offer your eyes in the last hour before sleep carries more weight than the same dark would at noon. Now a pattern is beginning to form. Cortisol follows a daily curve. A master clock keeps that curve in time. The clock is set, morning and night, by signals from the environment, and light is the strongest of them, read by special cells that speak directly to the clock. This means the evening level of cortisol is not fixed by fate. It is shaped, in part, by the signals you offer in the hours beforehand. We are circling closer to the central question. If light can hold cortisol up, then the careful removal or shaping of light might be one of the signals that helps bring it down. Before we leave light entirely, one more piece. Morning light matters for the night that follows. A dose of bright light early in the day, especially natural daylight, helps anchor the master clock firmly to the real hour. A well-anchored clock tends to produce a cleaner evening decline of cortisol many hours later. So the calm of a given night is partly written in that morning's first light. This is one of the quiet truths of the rhythm. The body keeps a longer memory than a single moment, and the signals you give it early echo softly into the dark. Light is not the only time giver, though, and the others become the heart of tonight's 3 minutes. The second great signal is temperature. Both the temperature of the room, more subtly, the temperature inside your own body. Your core body temperature follows its own daily rhythm, closely tied to the master clock. It is highest in the early evening and falls during the night, reaching its lowest point in the small hours before dawn. That nightly cooling is not a side effect of sleep. It is part of how the body prepares for sleep, and it is woven into the same timing system that shapes cortisol. The link between cooling and sleep is one of the more dependable findings in sleep science. As the evening deepens, the body begins to release heat, often through the hands and feet, allowing the warm core to cool. This drop in core temperature tends to occur in the same window when sleep most easily arrives. Researchers have found that the timing of the temperature fall and the timing of sleep onset are closely matched. The body is not waiting passively for sleep. It is actively cooling itself toward it, and the signals that encourage that cooling can help draw the whole rhythm gently downward. We have reached a first resting place, and the pattern is now clear enough to name. Cortisol is not the enemy. It is a rhythm, kept by a clock, and that clock is set by a handful of signals from the world around you, with light and temperature foremost among them. The central question can now be heard more precisely. If these signals set the clock, then offering the body the right ones, at the right hour, might be how you tell the brain that the time for high cortisol has passed. That is where the next arc begins, with how those signals travel and why they may act so quickly. Right now, somewhere behind your eyes, a small cluster of cells is keeping time. It does not need your attention to do it. It has been counting the hours of this day without a single instruction from you. The light around you has softened. The cells that report the hour have begun to quiet. And the clock, reading that quiet, has already started to lean toward night. The question that just opened, how these signals reach so deep, so fast, lives in this very moment. In the warmth leaving your hands, in the dimness your eyes are drinking in. You do not make any of it happen. Notice your breath. The rhythm is already turning. Now we continue. Let us follow the signal of darkness on its journey inward. When light fades, the time-keeping cells in the eye reduce their firing, and that change travels along their dedicated path to the master clock. The clock, now reading evening, eases its daytime instructions to the rest of the body. One result is that the brain allows the small gland that makes melatonin, the pineal gland, to begin its release. Another is a gradual loosening of the daytime drive that holds cortisol up. A single environmental change, the dimming of light, branches into several gentle effects, all pointing the body in the same direction. The pineal gland deserves a moment of its own. It is a tiny structure deep in the brain, and for centuries, its purpose was a mystery. We now understand it as the body's translator of darkness into chemistry. When the master clock signals night, the pineal gland releases melatonin into the blood, and that melatonin tells tissues throughout the body that the dark hours have arrived. Melatonin does not force sleep the way a sedative would. It is closer to a messenger announcing the time, lowering the body's resistance to rest. As cortisol steps down, melatonin's announcement is finally heard. It is worth being precise about what melatonin does and does not do, because it is often misunderstood. Melatonin is sometimes called the sleep hormone, but it is more accurately a darkness hormone. Its rise marks biological night, and in many people that rise helps sleep arrive. But it works gently, by shifting timing, rather than by switching consciousness off. This matters for tonight, because it means the most powerful lever is rarely a single chemical. It is the timing of the whole system, helping cortisol fall and melatonin rise together, on schedule, tends to do more than amplifying either one alone. Now compare two roads that a calming signal can travel. The hormonal road runs from brain to pituitary to adrenal gland through the blood, and it is thorough but slow, taking many minutes to unfold. The other road is electrical, carried by nerves, and it can act in seconds. The faster branch of the nervous system, the one that releases adrenaline in moments of alarm, has a partner branch that does the opposite. It slows the heart, lowers arousal, and helps the body settle. Many of tonight's environmental signals work, in part, by tipping the balance toward that calming branch. This calming branch travels largely through a single great nerve called the vagus nerve, which wanders from the brainstem down through the chest and abdomen. When it is active, the heart slows, breathing deepens, and the body shifts toward rest. There is growing interest in how gentle, deliberate actions, especially slow breathing, can raise the activity of this nerve. Some researchers describe the broader framework of how this nerve governs calm and connection as polyvagal theory, though it is worth noting that this theory remains debated and not fully settled. What is clearer is the simpler observation. Slowing the breath tends to slow the body. Breathing is unusual among the body's rhythms because it sits at a crossroads. It runs automatically, without thought. Yet you can also take its reins whenever you choose. This dual nature gives it a quiet power. By deliberately slowing your exhale, you send a signal through the calming nerve that the body tends to read as safety. Studies of slow breathing, often around 6 breaths per minute, have observed steadier heart rhythms and reported feelings of calm. The exhale appears to matter most. A long, unhurried out-breath is one of the few direct levers you hold over a nervous system that usually runs on its own. Here is why breath belongs in a conversation about cortisol. The stress branch of the nervous system and the cortisol-producing axis are linked. They often rise together, and, gently, they can fall together. When slow breathing quiets the fast electrical alarm, it removes one of the prompts that can keep the HPA axis active at night. The breath does not lower cortisol by magic. It lowers the arousal that was helping to hold cortisol up. This is part of why a few minutes of slow breathing, combined with the right light and temperature, can feel more immediate than waiting passively for a rhythm to turn on its own. Consider the speed of these pathways against the speed of a swallowed remedy. A pill first dissolves, then passes through the stomach and gut, enters the bloodstream, and reaches its target before it can act. A process that often takes 30 minutes or more. A nerve signal, by contrast, travels in the time it takes to read this sentence. When you dim the lights, cool the air, and slow your breath, you are not waiting on digestion. You are speaking to the body in its own fastest language, the language of nerves, which is part of the answer to why these signals can settle the body so quickly. Temperature now returns, with more detail. The body sheds heat largely through the skin of the hands and feet, where blood vessels can widen to release warmth. As evening arrives, these vessels tend to open. The extremities grow warmer, and the warm core begins to cool. This opening of distant blood vessels has a careful name: distal vasodilation, and its timing closely precedes the easiest moments for sleep. Warming the feet, oddly enough, can help the core cool faster because it encourages that release of heat. The body's path into sleep often runs, quite literally, through warm hands and a cooling center. A cool room supports this descent. When the air around you is slightly cool, the body can release its heat more easily, and the core temperature can fall toward its nighttime low. Sleep researchers often find that moderately cool sleeping environments are associated with easier, more continuous sleep. The exact comfortable temperature varies from person to person, so the gentle principle matters more than any single number. A room that lets the body cool, rather than holding its warmth in, becomes another environmental signal, telling the same clock that organizes cortisol that the hour for descent has come. There is a reason a warm bath before bed is such an old and trusted habit, and the science is quietly elegant. A warm bath or shower draws blood toward the skin and opens those distal vessels. When you step out, the body sheds heat rapidly from the warmed skin, and the core temperature then drops more steeply than it would have on its own. Studies of warming before sleep have observed that this pattern can help sleep arrive sooner. The warmth is not the point. The cooling that follows the warmth is the signal, an engineered version of the body's own nightly fall. Step back and notice what light and temperature share. Both are read by the same master clock. Both follow daily rhythms, and both can be deliberately shaped in the last minutes before sleep. This is the quiet architecture beneath tonight's 3 minutes. You are not inventing a new state for the body. You are gathering several of its natural evening signals and offering them at once, on purpose, slightly ahead of schedule. The clock, receiving a chorus of evening cues rather than a single one, can read the message more clearly, and the descent it was already preparing can begin a little sooner. The third great time giver is the timing of food, and it works through a fascinating discovery. The master clock in the brain is not the body's only clock. Nearly every organ, including the liver, the gut, and the pancreas, carries its own small clock, made of the same kinds of timekeeping genes. These peripheral clocks take their cues partly from the brain and partly from when you eat. Food, in other words, is a time signal. A meal tells the clocks of the digestive organs what hour the body believes it to be, and that belief ripples outward into the larger rhythm. This is why late eating can quietly disturb the night. When a large meal arrives close to bedtime, it tells the body's peripheral clocks that it is still daytime, the hour for fuel and activity. Those clocks can then pull against the brain's clock, which is reading the darkness and trying to wind down. The result is a kind of internal disagreement about what time it is, and a system at odds with itself tends to settle less easily. Easing the evening meal earlier and lighter removes one more conflicting signal. letting all the clocks point together toward rest. There is also a direct link between food, blood sugar, and cortisol. One of cortisol's daytime jobs is helping to manage blood sugar, releasing stored energy when the body calls for it. A heavy or sugary meal late at night can prompt swings in blood sugar that, in turn, can nudge the stress system into activity during the hours it was meant to be quiet. Acalmer. Earlier evening meal keeps blood sugar steadier through the night, removing another small prompt that might otherwise call cortisol back to work when its shift was nearly over. There is a quietness settling in now, somewhere between the words and the dark. You have been listening for a while, and your breathing may already have slowed without your asking. Take one easy breath, and let the exhale be longer than the breath that came before it. We are moving through this together. The science of how a body lowers itself toward rest, and we will keep going. Slowly, we can now gather the threads into a single idea. If light, temperature, and breath each speak to the systems that govern cortisol, then offering several of them together, on purpose, becomes a deliberate signal of evening. This is the quiet logic behind a brief nightly reset. You are not forcing the body into sleep. You are assembling a small chorus of the cues it already listens for, and presenting them clearly at the hour you wish to rest. The body, hearing many voices say the same thing, tends to believe the message more readily than when only one cue arrives alone. Why might several signals together work better than one? Because the clock and the nervous system weigh evidence. A single dim lamp is one vote for night. Dim light, a cooling room, a warm set of hands, and a slow exhale together form a stronger consensus. Researchers studying sleep often find that combined approaches tend to outperform any single change. And the reasoning is intuitive. The body is constantly estimating what time it is from many sources at once. When those sources agree, the estimate sharpens, and the descent the body was already preparing can begin with less hesitation. Now to the question of 3 minutes. Why might so short a span matter at all? The answer is that the fastest of these signals travel by nerve, not by hormone, and nerves act in seconds. A slow exhale can begin to steady the heart almost at once. Dim light begins to quiet the timekeeping cells immediately. A few minutes is enough time to send a clear, consistent set of cues and to let the fastest of them take hold. The reset is not about exhausting the body into sleep. It is about delivering a clean message in the body's own quickest language. Consider the first part of such a reset, the shaping of light. In the minutes before sleep, lowering the brightness around you, and especially removing bright bluish light from screens, lets the timekeeping cells in the eyes grow quiet. That quiet is read by the master clock as the arrival of night. Of all the signals, this one sets the stage, because light is the strongest time giver and the one most able to hold cortisol up when it lingers. Softening the light first is like lowering the house lights before a performance. It tells everything that follows what hour it is. The second part is temperature, offered to encourage the body's natural cooling. A slightly cool room lets the core release its heat, warming the hands and feet. By contrast, opens the distant blood vessels and helps that heat escape, so the core can fall faster toward its nighttime low. The two work together. A cool room to receive the heat, warm extremities to release it. This is why a warm shower, or simply warm socks, paired with cool air, can feel so settling. You are gently steering the body's temperature along the same downward path it follows on its own each night. The third part is the breath, the only one of these levers you hold consciously in the moment. Slowing the breath and lengthening the exhale in particular raises the activity of the calming branch of the nervous system carried by the vagus nerve. The heart slows, arousal eases, and one of the prompts that can keep the stress axis active at night is quietly withdrawn. A handful of slow breaths, each exhale a little longer than the breath before it, is often enough to begin the shift. Of the three signals, this is the one that acts most immediately. The order of these three has a gentle logic. Light first, because it sets the clock and prepares the longer hormonal rhythms. Temperature next, because the body's cooling unfolds over minutes. Breath last and throughout, because it acts in seconds and can carry you across the threshold itself. None of this has to be precise or effortful. The body is not grading your technique. It is simply reading signals. And the value of an ordered reset is that it offers those signals in the same sequence the body tends to follow on an unhurried evening of its own. It helps to be clear about what a reset actually changes, because the honest answer is modest and reassuring. It does not flood the body with sleep chemicals. It removes the cues that were keeping the body in daytime and supplies the cues of night, lowering arousal and helping the clock read the true hour. In effect, you are clearing obstacles from a path the body already knows. The descent of cortisol and the rise of rest were always scheduled. The reset simply stops postponing them, which is often all an out-of-step rhythm was waiting for. There is a kindness built into this rhythm worth noticing. A single calmer night tends to support the next. When the evening decline of cortisol happens on time, sleep arrives more easily. And good sleep, in turn, helps keep the following day's rhythm well-timed. Small alignments accumulate. This is the opposite of the spiral that worry can create, where one hard night feeds the dread of another. The same loop that can tighten can also loosen, and offering the body its evening signals, even briefly, is one way to start it turning in the gentler direction. We have reached the midpoint, and the central question can be heard with new weight. We asked what signal tells the brain that the hour for high cortisol has passed, and why it might settle the body faster than anything swallowed. We can now see that there is no single signal, but a small family of them: light and temperature and breath, traveling partly by nerve and partly by clock. Yet attention remains, and the second half of tonight follows it. If the signals are this simple, why does the rhythm drift in the first place? And what makes it hold once it returns? What just opened? The question of why a rhythm this old drifts away at all is not only a matter of biology. You may be carrying a version of it right now. Perhaps there have been enough late nights that the body began to expect them. Enough bright evenings that the clock learned the wrong hour. None of that is a failure. It is only a pattern, and patterns can be offered new information. The signals reaching you now, the dim around you, the slow breath, the cooling of the room, are that new information. You needn't believe in them. The body reads them whether or not you do. Feel the weight of your body where it rests. Notice that your breath keeps moving, even while the question stays open. Now we continue. Why does the rhythm drift? Largely because the master clock runs a little slow, on a cycle slightly longer than a day. Left without correction, it would drift later and later. Modern life supplies signals that push it later still. Bright evenings, late meals, irregular hours. The clock is not broken when cortisol lingers at night. It is simply set to the wrong hour, having been told again and again that evening was still day. The reset works because it offers the correction the clock was missing, the clear signal of night it needed to find its place again. Now we can answer more fully why these signals can act faster than a swallowed remedy. A pill first travels the long road of digestion before it reaches the blood and then its target, often a matter of half an hour or more. A nerve signal needs none of that. When you slow your breath, the message reaches the heart and the calming centers of the brainstem almost at once. You are not waiting on chemistry to be absorbed. You are using a pathway built for speed, which is why the first easing can be felt within the span of a few breaths. There is a deeper reason as well. A reset works with the body's rhythm. While many remedies work against the body's resistance, sedating the brain overrides its signals. Synchronizing the clock cooperates with them. When you supply the cues of evening, you are not fighting an alert system into submission. You are giving it the information it needed to stand down on its own. Cooperation tends to be quicker and gentler than override, because nothing in the body has to be forced. The descent was already prepared, and the signals simply lower the last barrier holding it back. Consistency turns a single reset into a lasting rhythm. The clock learns from repetition, and signals given at the same hour each night carry more weight than the same signals given at random. This is why a regular wind-down, even a brief one, tends to grow more effective over time. The body begins to anticipate it, lowering arousal before the reset even begins. You are, in a sense, teaching the clock a new expectation. The first nights ask for patience. The later nights tend to repay it. As the rhythm settles into a groove it can find without effort, morning returns to the story here, as a partner to the night. A clock anchored by bright morning light tends to produce a cleaner evening fall of cortisol many hours later. The two ends of the day are linked. By stepping into daylight soon after waking, you sharpen the morning peak of cortisol, and a crisp peak tends to be followed by a crisp evening decline. So the calm of a night is partly built that morning. The body keeps a longer memory than a single moment, and a well-lit dawn echoes softly into the dark that follows. It is worth distinguishing the rhythm's two kinds of cortisol release once more, because the difference shapes what helps. The first is the steady, clock-driven curve, rising at dawn and falling at dusk. The second is the reactive surge that answers a perceived threat at any hour. Nighttime worry triggers the second kind, sending cortisol up regardless of the clock. The reset addresses both. Its light and temperature cues support the clock's curve, and its slow breathing quiets the arousal that drives the reactive surge. One small practice speaks to two different roads by which cortisol can rise. When you wake in the middle of the night, it is helpful to know what is often happening. A brief awakening is a normal feature of sleep, occurring between cycles. And on its own, it is harmless. Trouble tends to begin only when the waking mind reads the moment as a problem, which can trigger that reactive surge of arousal and cortisol. The gentlest response is often the same family of signals. Keep the light low, keep the body warm and the room cool, and return to a slow exhale. You are reapplying, in miniature, the same message of night. The phrase "tired but wired" captures something real about a mistimed rhythm. The body can be deeply fatigued while the stress system remains active, holding the mind alert against the body's exhaustion. This happens when arousal and the cortisol curve are out of step, often after a stretch of late or stressful nights. The two systems disagree about what time it is. A reset helps them agree again, lowering arousal so that the fatigue the body already carries can finally be felt as the invitation to rest it was meant to be all along. Caffeine deserves a quiet mention, because it works against this very system. Caffeine blocks the signal the brain uses to register accumulated tiredness, and in some people, it can also nudge the stress response, keeping arousal higher for hours. Its effects can linger far longer than its taste, sometimes well into the evening from an afternoon cup. None of this is cause for alarm. It is simply useful to know that an earlier last cup gives the body more clear hours in which its natural evening signals can be heard without competition from a molecule designed to keep them quiet. Alcohol, too, plays a subtler role than it seems. It can bring drowsiness at first, which is why it is so often mistaken for a sleep aid. But as the body processes it through the night, it tends to fragment sleep and can stir the stress system in the later hours, sometimes lifting cortisol when it would otherwise be at its lowest. The early calm is borrowed against the later night. Understanding this gently is enough. The body's own evening signals, unlike a borrowed sedation, support the whole night rather than only its beginning. The peripheral clocks return now, with a fuller meaning, because the organs of digestion keep their own time, set partly by when you eat. A steady eating schedule helps keep the whole body's rhythm coherent. Meals at wildly varying hours send mixed signals, as if the body crossed time zones without ever leaving home. Regular meal timing, with the evening meal earlier and lighter, lets the peripheral clocks agree with the brain's clock. When all the clocks point to the same hour, the descent into night meets less internal resistance, and cortisol can fall without being called back to manage a late arrival of food. There is a graceful symmetry in how the body prepares for both ends of sleep. In the hours before your usual waking, the clock begins, quietly, to lift cortisol again, readying you to rise before the alarm ever sounds. The same system that lowers cortisol at night raises it before dawn. This is why a regular schedule feels so much kinder than an irregular one. The body can prepare for a waking it expects. The rhythm you protect at night is the same rhythm that lifts you gently in the morning, each end caring for the other. Movement during the day supports the night as well, though its timing matters. Regular physical activity tends to strengthen the daily rhythm and can deepen sleep. But vigorous effort very close to bedtime can briefly raise arousal and core temperature, working against the evening descent for a time. The body usually settles within an hour or two. The gentle principle is that daytime movement and nighttime rest are partners, not rivals, and that giving the body a margin between exertion and sleep lets the cooling and quieting it needs unfold without having to undo the heat of recent effort first. It is worth saying plainly that the goal is never to reach zero. Cortisol at night is not meant to vanish, only to fall to its low. A small, steady presence remains through the night, part of the background that keeps the body running while you rest. Chasing the complete absence of a stress hormone would be both impossible and unwise. The aim is rhythm, not erasure. This is part of why the reframing at the start matters so much. You are not trying to defeat cortisol. You are helping it return to the small, quiet level the night was always meant to hold. The body's clocks share a feature with all good timekeepers. They prefer regularity to intensity. One perfect night changes little, but a gently consistent pattern reshapes the rhythm over many nights. This is encouraging, because it means no single evening carries the whole weight. A missed wind down is not a setback to grieve. It is simply one night among many, and the clock weighs the pattern, not the exception. The reset is most powerful, not as a rescue for the worst nights, but as an ordinary habit that quietly keeps the rhythm where it belongs. Light's evening sensitivity gives one more practical gift. Because the clock is especially responsive to light in the hours before bed. Even modest dimming in that window carries outsized weight. There is no call to sit in darkness for hours. Lowering the light in the last stretch before sleep, when the clock is most willing to listen, accomplishes more than the same dimness would earlier in the day. The body's own schedule has handed you a lever that grows more sensitive exactly when you reach for it, which is a quiet piece of good fortune in the design. Worry has a physiology, and naming it can loosen its grip. When the mind circles a concern at night, it can keep activating the stress axis through pure thought, with no danger present in the room. The body cannot easily tell an imagined threat from a real one. This is humbling, but also hopeful, because the same imagination can be turned toward calm. Slow breathing, a cool room, and a dim light send the body real signals of safety that begin to outweigh the imagined signals of threat, gently tipping the balance from vigilance back toward rest. There is a reason that doing something with the hands and breath helps more than simply telling yourself to relax. The instruction to relax is a thought, and thoughts alone struggle to quiet a stirred-up body. A slow exhale, a warm cloth, a cool pillow. These are physical signals, and the body trusts physical signals more than spoken commands. This is the wisdom hidden in any wind-down practice. It gives the restless mind something real and gentle to do, while the actions themselves carry the message of night that words alone could not deliver. The vagus nerve, that great pathway of calm, can be gently encouraged in more ways than breath alone. A long, slow exhale engages it. So can warmth, stillness, and the simple safety of a familiar dark room. While the broader framework, sometimes called polyvagal theory, remains debated among researchers, the simpler observation is well supported. Conditions of safety and slowness tend to shift the nervous system toward rest. You needn't master any theory. You need only offer the body the unmistakable, ordinary signs that nothing here requires your guarding tonight. Sleep itself feeds back into the system that prepares it. A night of well-timed sleep helps keep the next day's cortisol rhythm crisp, which in turn supports the next night. This is the gentle flywheel beneath the whole story. Each aligned night makes the following alignment a little easier. It is the reason that the first nights of a new rhythm ask for the most patience, and the later ones ask for the least. You are not only resting tonight, you are tuning an instrument that will play a little more truly tomorrow. Consider how little the body asks of you in all this. It does not require willpower, or perfection, or belief. It asks only for a few honest signals of evening, offered with some regularity. The clock does the rest, as it has done for every ancestor who ever watched a fire burn low and felt sleep approach. There is relief in this. The work of rest is not yours to perform. It is the body's, and your part is only to stop interrupting it, to dim the light and slow the breath and let an ancient process resume. The phrase circadian rhythm simply means a rhythm of about a day, and nearly every living thing has one. Plants open and close on it. Single cells keep it. It is among the oldest patterns life has carried, far older than thought or worry. When you align your cortisol to its rhythm, you are not adopting a modern technique. You are rejoining a current that has been running through living things for billions of years. The night you are sinking into now is the same night your most distant ancestors trusted, organized by the same turning of light to dark. It is worth holding the difference between managing and allowing. So much of the day is spent managing, deciding, controlling. Sleep is the one great act that cannot be managed into being. It can only be allowed. The reset is not a method of control. It is a way of stepping aside, of clearing the signals of daytime so the body can do what it already knows. This shift, from doing to allowing, is itself part of the descent. The moment you stop trying to make sleep happen is often the moment the body finds its own way down. Notice that everything we have described converges on a single quality: slowness, slow light, fading, slow cooling of the core, slow breath, lengthening. The body reads slowness as a sign that the demands of the day have passed. Speed belongs to the morning, to the surge of cortisol that readies you for what waits. Slowness belongs to the night. In offering the body slowness through several signals at once, you are speaking the dialect of evening, and the rhythm, hearing its own language, leans the way it was always going to lean once the rush of the day finally eased. Here the intellectual answer comes fully into view. Cortisol is not a problem to be solved, but a rhythm to be retimed. And that rhythm answers to signals you can offer in a few quiet minutes. The brain reads light and temperature and breath as the hour itself. And because some of these signals travel by nerve, they can act faster than anything that has to be absorbed. The remaining facts carry a different quality. We have followed the mechanism as far as it goes. What is left is not more explanation, but the simpler truth that lives underneath it. Breathe slowly. The tide goes out twice a day without ever being told. The sky darkens each evening without effort, without intention. None of it hurries, and none of it strains against itself. Right now, inside you, the same kind of unhurried turning is quietly underway. The warmth is leaving your hands. The light has gone soft. A hormone that rose at dawn is easing toward its low and quiet floor. You are part of that same slow movement, the same patient turning of the world. There is nothing to push, nothing to force. You have only to let it continue at the gentle pace it already knows by heart. We are almost there now. There is something steadying in knowing the body keeps its own time. Whatever the day held, however late the hour feels, the clock beneath your thoughts is still turning toward night. It does not consult your worries. It simply counts the dark and prepares you for rest, as it has done every night of your life, including the ones you do not remember and the ones you feared you would never get through. There is nothing to earn in this rest. The fall of cortisol toward its quiet floor is not a reward for a day well spent. It comes for everyone, the calm and the anxious alike, the moment the signals of night are allowed to arrive. There is no test to pass first. Tonight, you have only to let those signals in and to stop standing in their way. Notice how the worry about sleep is itself a kind of wakefulness. The fear that a long night will harm you is the very thing that can keep the night from arriving. But that fear, too, is only a signal, and it can be answered with a gentler one. A slow breath, a dim room. The body believes what you show it, far more than what you tell it. The hands grow warm. The core grows cool. Somewhere in that small exchange of heat, the body crosses a threshold it has crossed thousands of times before. You will not feel the exact moment. No one ever does. Sleep arrives the way evening arrives, without announcement, quietly, while you are looking the other way, thinking of something else entirely, or perhaps of nothing at all. Every cell in you keeps a kind of clock. Your liver, your skin, your blood, all of them counting the same slow hours. Tonight they are agreeing, quietly, that the day is done. There is a peace in that agreement, a whole body leaning, together, in one direction, toward dark, toward rest, toward the floor where the long curve of the day finally comes down. You have done this before, thousands of nights. You have made this same descent, and thousands of mornings. You have risen from it again. The body remembers the way even when the mind has forgotten how to trust it. Let the body lead now. It knows the path down better than any thought could ever hope to map, and it has never once lost the way. The light is low. The room is cool. The breath is slow. 3 small truths, and the body has already begun to believe them. There is nothing left to arrange, nothing left to decide. The signals have been sent, and now the only task is the gentlest one there is, which is to receive what you have already, quietly, set in motion. Cortisol is falling now, the way it falls every night. Toward the small, quiet level the dark was always meant to hold. You cannot feel it falling, but you can feel its effects. The loosening, the heaviness, the slow surrender of the shoulders into the bed. This is the rhythm doing what it knows how to do. You are simply along for the gentle descent. Think of how the tide goes out. No effort, no decision, only the pull of something larger and far older than itself. Your sleep is like that tonight. Not something you make happen, but something that happens through you, drawn quietly down by a rhythm that has never once forgotten its way to the far shore of morning. And back again. There is no hour to reach, no sleep to perform, and nothing at all to accomplish here. The night asks nothing of you that you are not already doing simply by lying still and breathing slow. Let that be enough. Quiet one. It is enough. It has always been enough. On every single night you were certain that it wasn't. The mind may still offer a thought or two. Let it. Thoughts at this hour are like leaves on dark water, drifting past without ever needing to be caught or answered. You can watch them go. None of them require anything of you tonight. None of them can keep the tide from going out. Now that it has quietly begun, your breath has slowed without your asking. Your body has grown heavier without your effort. These are not things you are doing. They are things that are happening. Gentle proofs that the descent is already underway. That the rhythm has taken over the work. That you are free. Now, to loosen your grip and stop holding on to the day. Sleep is the body's oldest healing. Older than medicine. Older than memory itself. While you rest, the quiet repairs of the night begin. The ones researchers are still working to understand fully. You needn't know how they work, or trust them, or help. You have only to let them happen. The body has been doing this since long before you ever learned its name. There is a clearing that comes with rest, a settling of the mind's restless water until it goes still and clear. You will not watch it happen. You will simply wake, somewhere on the other side of the dark, and find that the night has done its quiet work without any help from you at all, as it always has. Notice the room around you holding still. The dark is not empty. It is full of the same safety that has wrapped every sleeping creature since the first night ever fell across the world. You belong to that long and unbroken line of rest. Tonight, you take your place in it. Quiet one. As easily as one long breath flowing slowly out. The work of the day is finished, whether or not it is done. There is a difference, and the night knows it well. Done can wait for morning, and morning will come. Finished is all that sleep requires, and you are finished now. Set down, released, allowed at last to be carried for a while, rather than always to carry. Feel how little is being asked of you. No effort to make. No problem to solve. No hour to keep watch over. Only the soft arithmetic of a body cooling, a breath slowing, a hormone coming gently down. It is the simplest math there is, and it is solving itself, slowly, without you needing to check the answer or even watch it happen. If sleep has not come yet, that is all right too. It is not late. The signals are working whether or not they have finished their work. Rest is gathering at the edges of you, the way light gathers softly before dawn, and it will arrive in its own good time, asking nothing of you but to keep breathing slow and low. You are safe here. The doors are closed. The day is behind you, and the small ancient clock inside you is keeping watch over all the hours, so that you needn't. Let it. That is its quiet work, and it does it well, as it always has. Yours is only to rest beneath its patient, unhurried counting of the dark hours. Everything is slowing now. The light, long gone soft. The breath, long and even and unhurried. The body, heavy and warm and cool in all the right places at once. There is a rhythm carrying you, and it has carried you before, every night of your life, and it will not drop you now. It never has, not once, in all your nights. Let the last of the day dissolve. The worries you carried in with you are not yours to hold tonight. Set them down on the dark water and watch them drift, lighter and lighter still, until they are only small shapes far out, and then not even that, and then only the wide and gentle quiet that was always there underneath. The hormone that woke you this morning has nearly reached its quiet floor. The one that rises with the dark is taking its place. This is the handover the body performs every night, the changing of a soft and silent guard. And it is happening in you right now, smoothly, gently, exactly as it was built so long ago to do. There is nothing more to understand. The knowing was only ever a way of trusting, and the trust is here now, settled deep in the body, deeper than any single fact could reach. You can let all the words go. They have done their quiet part. What remains is older than language, and it is gently, surely taking you down. Almost there now. The threshold is close, the one you cross every night without ever once seeing it. Your breath already knows the way. Your body already knows the way. There is nothing left for the mind to do but loosen its very last hold and follow them both down into the dark that has been waiting, patient and kind, all along. And here, at the last, is the simplest truth of the night. You were never meant to fight the hour. You were only meant to return to it. The signal that tells the brain to come down is not a force you apply, but a permission you give. And the body, hearing it, does the rest the way it always has. There is nothing in the night to switch off. You have only to let it find you. It already has. Something has come down tonight that did not come down before. Not forced, not willed, only allowed. The cortisol that held its ground at the start of this hour has eased toward the floor. The dark was always keeping for it. And the body, given a handful of honest signals, knew exactly what to do with them. The dim light, the cooling core, the long, slow breath. None of them commanded anything. They only told the truth about the hour and the rhythm. Hearing it, leaned the way it had always meant to lean. The night was never the enemy. It was only waiting to be told it had arrived. The deep sleep, guided by Mind Science playlist, has been moving through the body's quiet machinery, one rhythm at a time. The next video traces the thread further, into the part of the night this one only began to reach. That video is waiting whenever you are ready. Let the last edges of yourself grow soft, the way warmth leaves the skin and disappears into a cool and waiting dark. Let your breath go where it wants to go, slower and slower, until you are no longer the one guiding it. If sleep comes, let it carry you down to the quiet floor where the day is finally, fully set down. But if your eyes are closed, stay there. Rest well, quiet one. You were never meant to hold the night up. It was always meant to hold you, where science becomes the softest place to rest. Good night.